We have an object held at an unknown height. So the unknown height, the height is unknown. And it's on the Earth, and it's a small height because g is constant. It's released from rest, so v0 is 0. Determine the speed the instant it makes contact with the ground. So we're looking at that final velocity. So which of the equations could the student use to determine the speed using the fewest measuring tools possible? So if we look at the first equation, we have Vz equals At plus V0. Now we know V0 is 0. We know the acceleration is 10 for our purposes here. So if we had a stopwatch to measure the time, we could calculate the velocity. So this first one requires only 1. Since it requires only 1, it's hard to imagine fewer than 1, so this must be one of the correct answers. Let's go further. We'll consider the second equation. Z equals 1/2 AT squared plus V0t plus Z0. And if we set this equal to 0 and this the final, like say maybe it's 10 meters or something that we measure, we don't need the Z0. We know the initial velocity is 0. So we're left with Z equals 1/2 AT squared. And Z then is 1/2 of 10 times T squared. Now what this is going to do for us, if we measure the time, it's going to give us the position. And if we measure the position, it's not going to give us anything new, and it's not going to give us that final velocity. We have to use another equation to get it. So this one is out. We move to the next equation. V squared equals V0 squared plus 2A delta X. V0, we've already established, is 0. So the V squared we're looking for would be twice times 10 times delta X. So if we use a meter stick to determine delta X, we can calculate V, and this looks like it has 1. So right off the bat, it looks like those are our two answers, but we will examine the last one. The last one, V bar equals X minus X0 over delta T. Now we can measure this with a meter stick. And we can measure this with a timer. But that's only going to give us the average velocity. We can get the final velocity, but we would need to use a second equation to do it. So clearly we are already at 2 measurements here, and we have to invoke an equation that we haven't been given permission to use. So it is the first and the third answers.